Good morning, students. As you all know, we have started lesson number 2, Work and Energy from Science 1. Today, children, we are going to learn about energy. So, let's begin. Children, can you tell me why does this happen? If a pot having a plant is kept in the dark, the plant languishes. That means it becomes weak. On increasing the volume of a music system or TV beyond a limit, the vessels in the house starts vibrating. Collecting sunlight on a paper with the help of a convex lens burns the paper. Children, the capacity of a body to perform work is called its energy. The units of work and energy are the same. The unit in SI system is joule, while that in CGS system is erg. Okay, children. What is energy? We have learned that energy exists in various forms like mechanical, heat, light, sound, electromagnetic, chemical, nuclear, and solar, isn't it? In this chapter, we are going to study two forms of mechanical energy, namely potential energy and kinetic energy. Are you getting me, children? We are going to learn these two types of energy. So first, let us begin with kinetic energy. What will happen in the following cases? Observe the figure carefully. A fast cricket ball strikes the stumps. The striker hits a coin on the carom board. One marble strikes another in a game of marbles. Children, from the above examples, we understand that when a moving object strikes a stationary object, the stationary object moves, right? So, the moving object has some energy, part or all of which it shares with the stationary object, thereby setting it in motion. Are you getting me, children? So, we can say that the energy which an object has because of its motion is called its kinetic energy. The work done by a force to displace a stationary object through a distance s is the kinetic energy gained by the object. Kinetic energy is equal to the work done on the object. So we can write kinetic energy is equals to F into S. Understood? Expressions for kinetic energy. Suppose a stationary object of mass m moves because of an applied force. Let u be its initial velocity. Here u is 0, right? So let the applied force be F. This generates an acceleration A in the object, and after time t, the velocity of the object is equals to v. The displacement during this time is s. So we can say the work done on the object, that is W, is equals to F into S. According to Newton's second law of motion, F is equals to M into A. Let us give this equation as 1. Similarly, using Newton's second equation of motion, S is equal to ut plus 1 upon 2 at square. However, as initial velocity is 0, so u is equal to 0. So S is equals to 0 plus 1 upon 2 at square. So we can write S is equals to 1 upon 2 at square. Let us give us equation 2. W is equals to MA into 1 upon 2 at square. By using equations 1 and 2, we get this equation. W is equals to 1 upon 2 at square. This is our equation number 3. Now, using Newton's first equation of motion, V is equals to U plus AT. So, therefore, V is equals to 0 plus AT. We get V is equals to AT. So we can write this V square is equals to AT the whole square. This is our equation number 4. We get W is equals to 1 upon 2 mv square by using equation number 3 in equation number 4. Children, therefore, the kinetic energy gained by an object is the amount of work done on the object. Therefore, kinetic energy is equals to W, that is 1 upon 2 mv square. So, this is the formula for kinetic energy. Kinetic energy is equals to 1 upon 2 mv square. Children, a stone having a mass of 250 gram is falling from a height. How much kinetic energy does it have at the moment when its velocity is 2 meters per second? So let us solve this problem. Okay? What is given here? Mass 250 grams, which if we convert it into kilogram, we get 0.25. V is equals to 2 meters per second. What is the formula for kinetic energy? 1 upon 2 mv square. Right? So let's substitute now. 1 upon 2 into 0.25 into 2 square. After calculation, we get the answer 0.5 joule. Joule is the unit. Children, use your brain power. If the mass of a moving body is doubled, how many times will the kinetic energy increases? If the mass is doubled, the kinetic energy will also be doubled. Got it? Now let's study potential energy. Now children, try this activity. An arrow is released from a stretched bow. Okay. Water kept at a height flows through a pipe into the tap below. A compressed spring is released. Which words describe the state of the object in the above examples? Answer is the word stretched, kept at a height, and compressed describes the state of the object. Isn't it? Yes. Children, where did the energy required to cause the motion of the object come from? The energy required to cause the motion of object comes from the energy stored in the system. That is potential energy of the system. Understood? Good. If the objects were not brought in those states, would they have moved? Think this? Yes, absolutely correct. The answer is no. The energy stored in an object because of its specific state or position is called its potential energy. Now let's try this activity. Hold a chalk at the height of 5 cm from the floor and release it. Its speed is very less as it falls to the ground. Now stand up straight and then release the chalk. What will happen then? The speed of the chalk is much more as it falls to the ground compared to case 1, right? Is there a difference in the result of the two activities? If so, why? The answer is the difference is due to the initial potential energy of the chalk. The greater the initial potential energy, the greater will be final kinetic energy. Are you getting me, children? Good. Expression for potential energy. To carry an object of mass m to a height h above the Earth's surface, a force equal to mg has to be used against the direction of the gravitational force. The amount of work done can be calculated as follows. Work is equal to force into displacement. W is equals to mg into h. Therefore, we can write W is equals to mgh. The amount of potential energy stored in the object because of its displacement. So potential energy is equal to mgh. That is, work is equals to potential energy. Displacement to height h causes energy equal to mgh to be used or stored in the object. Understood, children? Now let's see an example. 500 kilograms water is stored in the overhead tank of a 10 meters height building. Calculate the amount of potential energy stored in the water. So let's calculate this. What is given? Height 10 meters. Mass is 500 kilogram. Gravity, we know it is 9.8 meter per second square. Therefore, potential energy is equal to mgh is equal to 10 into 9.8 into 500. After calculating all these things, we get our potential energy as 49,000 joule. Easy? Good. Potential energy. Ajay and Atul have been asked to determine the potential energy of a ball of mass m kept on the table as shown in the figure. What answers will they get? Will they be different? Let's find out the answer. What do you conclude from this? Yes, potential energy is relative. The height of the ball with respect to Ajay and Atul are different, right? You can observe in the picture. So the potential energy with respect to them will be different. Potential energy of the body with respect to Ajay is mgh1. Potential energy of the body with respect to Atul will be mgh2. Understood, children? So, m is equals to mass of the ball and potential energy is relative. Therefore, it depends on the values of h1 and h2. Hence, it will be different in both the two cases. Understood, children? Good. With this, we have finished our today's lecture. We shall meet you in the next lecture with a new topic. Till then, children, read the lesson and watch the video attentively. Thank you, children.